Hi Level 2s and welcome back to 2.4 Atomic Structure and Bonding, and we're doing Lesson 6 on ionic substances or ionic solids. So here's a summary table, and this should hopefully reinforce what we've been learning. So this is part B of this lesson, by the way. So the type of particle in an ionic solid are ions. The type of bonding or the force between particles is ionic bonds, nice and easy. If they ask you about conductivity, we know there need to be free moving charged particles, ions or electrons. Solid ionic substances cannot conduct because those ions are locked in that rigid lattice and therefore they cannot move, so they can't conduct. Whereas though molten or dissolved in water, they can conduct because the rigid structure has been broken down and the ions can move. So you've got to link it back to what the charged particle is. In an ionic substance, it's ions, and you've got to link it to being able to move. So in the solid, they can't move. In molten or aqueous, they can. Melting point, also with the strength, metallic bonds are super strong, so they take a lot of energy to break, linking always back to energy when you're talking about melting point, because that's breaking the substance down. Will ionic substances dissolve? Most of them will, but it'll depend on the attraction. So if the attraction for the water molecule and water are stronger than the attractions holding the ions together, then it will dissolve. If the ionic bond is stronger, then it won't dissolve and it's insoluble. Can it withstand pressure? Okay. An ionic lattice, even though it's brittle, which means if it's hit, it'll shatter, it's actually quite strong, which means if you press it, it can withstand a lot of pressure. So if you squeezed on a tiny crystal, it would be quite strong. And the reason why is because ionic bonds are really strong, which makes that rigid lattice really strong. We can forget about malleable here, we're talking about brittle. So is it brittle? And the answer is yes, very. That should say yes, that's a terrible typo. If hit with a hammer or something like that, then cations come in contact with cations and like charges repel, so it causes the entire structure to become brittle and fracture, and that's really important, okay? And so that they are definitely brittle, okay, and they are not ductile, and the reason why is because the bonds are directional. So those ionic bonds, if you remember back to the lattice, it is one cation for one anion, and so those ions are locked there in a directional bond, and so therefore it cannot be drawn into wires. Okay, yeah, well, actually, I think that part should have been down there, so I'll tidy that up for your notes. Apologies about that, but hopefully that's made sense in this wee little video. Okay, so moving on to some examples like I did with metallic substances. So remember, the structure for an NCA answer is going to be describe the structure and then describe the bonding, so you must talk about electrostatic, define the property you're talking about, and then justify that property. Okay, folks. So let's say I'm asking you about melting point here. Okay, so it could be for any ionic substance. So first of all, we say an ionic solid is a rigid 3D lattice where cations are surrounded by anions and anions are surrounded by cations. Then we need to talk about what the ionic bonds are. The cations are attracted to the anions by strong electrostatic attractions called ionic bonds. These two you will memorize and you'll regurgitate each time. Melting point, so we've got to state what that is. So for a substance to melt, which means turn from solid to liquid, some of the forces must break. As ionic bonds are very strong, they require a large amount of energy to break, which is why the melting point is high. Hopefully that makes sense. How about electrical conductivity? These two are exactly the same as the previous slide, okay? So I'm not going to repeat those every time, but hopefully you're seeing the picture here where we describe the structure and then we describe the ionic bond. So now this is to conduct, so you should always put this definition in. So to conduct electricity, there must be free moving charged particles, ions or electrons, okay? Solids, they don't conduct electricity. That's because the ions are locked in a fixed position in the lattice and they cannot move. So you must link it to cannot move. When heated and it becomes molten, or if dissolved in water, it will conduct because the rigid structure is broken and ions can move and carry a charge. So hopefully that makes sense. How about ductile? Again, these two are the first two that are just literally, you remember every time. Rigid 3D lattice, cations surrounded by anions, anions surrounded by cations. You'll do this so much that you'll be so bored of it. So cations are attracted to the anions by strong electrostatic attractions called ionic bonds. So ductile is the ability of a substance to be drawn into a wire. Because sodium chloride, the ionic bonds are directional, they cannot stay together when stretched, and so it is not ductile. Hopefully that makes sense. Brittle. Again, first two are the same. I won't say them again. You're probably really sick of me talking as well. So brittle is when a substance is hit by a force and it shatters. So if distorted, the cations will come in contact with the other cations and repel, which causes the structure to become brittle and fracture. Okay, so like charges repel. Last one here, I think, is dissolving in water. Again, the first two are the same, so rigid 3D lattice where cations are surrounded by anions and anions are surrounded by cations. The cations are attracted to the anions by strong electrostatic attractions. So sodium chloride dissolves in polar water as the negative chloride are attracted to the positive hydrogen atoms, remember atoms of water, and the positive sodium ions are attracted to the negative oxygen atoms of the water. These attractions are stronger than the electrostatic attractions between the ions, and that's why it can dissolve. I'm hoping this is all making sense. Please flick me a question on Teams if it doesn't, and we're going to do a few activities together when we go live. So the final task for today, I'd love you to pause this and spend 5 minutes just chucking in like a yes, no, and just like single words or maybe like a couple of word answers. And I'm going to mark it now. So in an ionic solid, the type of particle are ions and the type of bonding is ionic. Okay, will it conduct? Yes, if molten or aqueous, as the ions can move. Is it malleable? No, it's brittle, because if you hit it with force, cations come in contact with cations and anions come in contact with anions and they repel. Is it ductile? Nope, because the ionic bonds are directional. Is the melting point, what's the melting point and boiling point like? High, because ionic bonds are super strong, so they take a lot of energy to break. Will they dissolve in water? Yes, some of them will. The ones that do, it's because the attractions of the ions to water are stronger than the ionic bonds. And the ones that don't, the ionic bonds are stronger than the attraction of water to ions. Hardness, yep, ionic bonds are strong, makes the lattice strong, and so therefore they're hard, so they can withstand pressure. So let's talk about metallic. So the type of particle are cations and delocalized electrons. The type of bonding are metallic bonding. Will it conduct? Yep, it's got free moving charged particles, in this case delocalized electrons. Is it malleable? And the answer is yes. There are non-directional bonds. It's ductile, yes, because there are non-directional bonds. Its melting and boiling point is high because metallic bonds are strong. And solubility in water, it's going to be a no because the metallic bonds are too strong. And its hardness, yes, they're very hard with the exception of sodium, magnesium and lithium. I don't think you need to memorize those, and that's because metallic bonds are strong. So hopefully that's all made sense. I will see you on Teams shortly. Okay, bye.